Hello everyone. Today we shall look at the concept of recurring decimals. Recurring decimals, we usually have them in our Igcse mathematics. Now first, what are recurring decimal, or what is a recurring decimal? The word recurring means there's a particular number or digits or group of digits that keeps occurring without end. There's a continuous occurrence of a digit or a group of digits. So we say recurring decimal. A recurring decimal is a decimal with a digit or group of digits repeated continuously. So repeated continuously, or we can use the word indefinitely, repeated without end. Okay, let's take examples. Look at 0.6666666. This is a typical example of a recurring decimal, as we observe that 66666 keeps reoccurring without end. That's why you see the use of the ellipses. You have the dot 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 to show continuity. That is, we have the number 666 being repeated without end. That's a typical recurring decimal. 0.712, So what do we do? What did we notice? We noticed that 712 keeps recurring and it reoccurs without end. That's typical recurring decimal. That's why you see the use of the ellipses to show continuity. So this actually shows continuity. That is, the recurring decimals occur without end. Okay. Now let's see from the images we have 0.6666666 like that without end. So the recurring digit is actually 6. The recurring digit is actually 6. So we can shorten that as 0.6 and we'll put a dot on top. Now the dot on top, the 6, is to show that the 6 is the digit that keeps recurring. Let's look at the second image. We have 8.24 like that in that pattern. Dot 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 to show continuity. So that's 8.24. So we notice that the digit or the group of digits that keeps recurring is 24. So that's why we need to place two dots. We need to place the dot on 2 and 4 to show that 24 keeps recurring. Let's see the last one we have there. We have 5.4821, 821, 821, 821, 821 like that in that pattern. Now this is equal to 5 points. Now the digits that keep recurring, or the group of digits that keep recurring, they are 821. We see it there, 821. Notice it here too, 821. Notice it here too. Observe it here, 821. So we have 5.821. So 821 keeps recurring. So instead of saying we place the dot on the 3 digits, we know that those 3 digits keep recurring. So we just show that the first recurrence occurs at 8. and the last one occur at 1. So that means recurring digits are 821. So implication of that is 821 keeps recurring, but notice that we show only the dot on 8 and on 1. So everything bounded in this region keeps recurring. So the dot is like, in this instance, used to show the boundary of the recurrence from 8 to 2 to 1. So that's, in this sense, we actually have 3-digit reoccurrence here. 3-digit reoccurrence. So 8, 2, and 1. So that's 5.821, 821. Sorry about that. We omitted 4. So we have 4 first, 5.4. Then before the recurrence of 821. So we have 821. 5.4, 821. So the recurrence occurs at 8 and ends at 1. So that in recent is written as 5.4. Then recurrence of 8, 2, and 1. Starting boundary 8, ending boundary at 1. So recurrence of 8, 2, and 1. So we write 8, 2, 1, another 8, 2, 1, like that, 8, 2, 1. Okay, let's see more example of recurring decimals, and let's try to interpret them. We have 0.4. Now, we're going to be interpreting each of these. 0.4, and the dot is placed on the 4. What does that mean? It actually means 0.4. So recurrence of 4, 4, 4, 4, 4, like that. Okay. 0.17 means 0. So keep recurring 17. Basically, in all recurring decimal, there is no end, so it's indefinite. So this is how we show indefinite in math. Now 0.250. Let's show the next one. 0.250. Now the dot is placed on 2 and on 0. So that means we have 0.250. So recurrence occur start at 2 and ends at 0, including 5. So 0.250, another 250, 250, 250, 250, like that. It has no end. 0.8, and the dot is placed on 8. Simply means 0.88888888, like that. So let's see. Try to open up each of those recurring decimals. 0.159. 0.159. So in real sense here we have 3-digit recurrence from 1, 5, and 9. So this simply means 0.159, recurrence of 3 digits, 159, 159, from 1 up to 9. So we have 1 to 5 to 9. 159, 159, like that. 159 in that pattern. So this is similar to this. 0.045, 0.045. So let's open up this. This is actually 0.0. Repeat 45, 45, 45, 45, 45, like that. 45. Okay. Let's move on. 0.558. So start from 5, end at 8 for the recurrence. So we have 0.558. Okay, continue again, another 558, 558. So that means here we have 3-digit recurring decimal. Here we have 2 digits recurring decimal, 1 digit of recurring decimal. Okay. So we're on 0.558, so that's 558, like that. Continuity. 0.12, the dot is placed on the 2. So here simply we have how many digits of recurrence? How many digits of recurring decimal here? Okay, that's actually 1. So 0.12. So This simply means let's try to open it up. If you open it up, that's 0.1. Then we now start recurring the 2. So the 2 continues, 2, 2, 2, like that. So this continuity 0.207. So we need to know the number of digits of recurrence. 0.207. How many digits of recurring decimal? Just only one. Okay. So interpretation of 0.207 means 0.2077777, like that. 77. So that's the recurrence. 0.35. Okay, so this is actually similar to this. We're actually repeating 2 digits. So the dot is on the 3 and the 5. So it's at 0.35, 35, 35, like that. So you can try to pause the video and try to see if you'll be able to find the write out in full the recurrence of this one, that's 2, 3, 4, and 5. So pause the video, try to see if you can get the full, write it out, add them out in full the recurring decimals. So 0.063. So the recurring digits are actually 2 recurring digits, 6 and 3. So they have 0.063, another 63, 63, 63, 63. So this is what we have there. So recurrence on 6 and 3, 63, 63, 63, 63. Okay, 0.08. 0.08. Okay, let's try to write out in full. 0.08. We repeat 0.8 again. Repeat 0.8. Repeat 0.8. Repeat 0.8, like that. Continuity 0.51. So we repeat 2 digits. 2 digits are being repeated. That's 0.51, 51, 51, 51, 51, 51. In real sense, for recurring decimal, you cannot exhaust the list. So because it's indefinite, so 0.1, and we have the dot placed on 1, so that's 0.111111111, like that. Keep repeating the 1. That's no end. 0.27, dot into this, the dot is on the 7. Now very important that we need to understand that how many recurring digits do we have here? We have only one recurring digit. That's very important because it will help us when trying to convert recurring decimals to fraction. So this is actually 0.2. So we'll start repeating the 7, 7, 7, 7, 7, 7, 7, 7. Now let's look at the next thing. How do we convert recurring decimals to fraction, which is the most important thing as with respect to this lecture. Now to convert recurring decimals to fraction, here are the rules. Here are the rules. Recurring decimals to fraction, we have the rules there. Now, but we need to take some examples to understand how to use these rules. Okay, so while I take the examples, you will see the process of using the rules. So let's start with a very easy one. Let's convert, or let's say we want to write the recurring decimal. Write the recurring decimal. So you can take your time to write out those rules in your note or your jotter. Write the recurring decimal 0.6 dot as a fraction. So we'll start from the easiest example. So despite the fact that these examples are quite easy and straightforward, we also meet them in our examinations. So write the recurring decimal 0.6 dot as a fraction. So you can follow through the steps, then after one or two examples, you must have mastered the steps. The first thing is to let your recurring decimal, let's call it x, let x to be equals to the recurring decimal 0.6 dot. Now, I would like us to do one thing. To open it up, we understand now that 0.6 dot means that 0.6666666 like that. Okay, so once we understand that, very good. Now the next thing is you need to determine the number of recurring digits. How many recurring digits do we have? We have only one recurring digit. Notice it's only this 6 here that keeps recurring. Only one recurring digit, okay? So once we understand that, we're fine. So only one recurring digit, 6. Now, if there's only one recurring digit, we will multiply by 10. If there are two recurring digits, we will multiply by 100. If there are three recurring digits, we will multiply by 1000. Notice, one recurring digit, 10. Two recurring digits will multiply by 100, that's 20. Three recurring digits will multiply by 1000, and that's 3 zeros. So that's what. So I'm actually in step 3 anyway, but I'm actually explaining the steps in the easiest way. Okay. So here, because we have just only one recurring digit, simply means we're going to multiply by 10. So let's multiply by 10. So if we multiply by 10, we have x times 10. So this first part multiply by 10. This second part also multiply by 10. And I'll show you the process of going about that. So x times 10, that's 10x, equal to. Now, we want to multiply this one by 10. Now, but the full form is actually what we have here. So we're going to use the full form. We're going to use the full form. So let's multiply this full form by 10. So multiplying it by 10, just shift the decimal point once forward. So if you do that, that's like 6.66666666 like that. Okay. So our answer here will be 6 point, this is what we're actually multiplying by 10. But to do it in the easiest way, I said we'll write out the full form, then use the full form, this full form, multiply this full form by 10. And that's what I've just done. And that's 6.66666 like that. So we notice another recurring digit of 6 again, 66666. So that's like 6.6. So the recurrence of 6666, you can just put dot on it. Now, what is my aim? Our aim is to make sure that the recurring part is eliminated. Our aim is to ensure that the recurring part is eliminated. Now, you notice that here we have only one recurring part, one digit of recurring. Here also, we also have one digit of recurring. So, one digit of recurrence on both sides. One digit of recurrence on both sides. Now, we can now subtract. So, that's why you see in step 4 says subtract 1 from 3. So, now I'm already in step 4. Okay. So let's carry out the subtraction. Now to do this subtraction, I will say 10x minus x, then I have 6.6 dot minus 0.6 dot. Our aim is that recurrence must disappear. So 10x minus x will give 6.6 dot minus 0.6 dot. 10x minus x, that's 9x, equal to, I like to do it manually, 6.6 dot minus, at this point, our aim will be such that the dot must eventually disappear, or the recurring digit must disappear. Okay, let's look at the result. 6 dot minus 6 dot, that's like 0. 6 minus 0, that's 6. 6.0 is same thing as 6. So you have 9x equals to 6. Let's divide through by 9. Let's divide through by 9. On dividing through by 9, we have x equals to 9x over 9 equals to 6 over 9. 9 cancel 9, x equals to 6 over 9. We can still divide in the smallest term. 3 in 6, 2, 3 in 9, 3. So x is 2 over 3. So we have been able to express that recurring decimal as a fraction to the simplest fraction. So that recurring decimal to the simplest fraction is 2 over 3. Now you can double check with your calculator. Just input 2 over 3 in your calculator and you see a recurrence of 0.66666666 like that. Okay, that's number 1. Let's take number 2 example. Number 2 example will be from the IGCSE math past question. So we have question 3. Sorry about the calculator that pops up. So we have question 3 of Mathematics 0580 2019 paper 22, February March. Okay. Let's have the question. The question says, write the recurring decimal write the recurring decimal 0.23 as a fraction. So let's have the solution. First, we need to be very observant and notice the number of recurrence digits. So first we say let x equals to 0.23 dot, and I always advise we write it in full. 0.23, so another 23, 23, these have been explained, 23 in that pattern. Basically it has no end. Okay, so this is just used to show that it continues. So if you like, you might not show this so you won't get confused. So this is just what we have. So when we have that, another thing is, how many recurrence digits do we have? We have 2 recurrent digits. Now when we have 2 recurrent digits, we will multiply by 100. So that's why we have 2 zeros here. If you have 5 recurrent digits, we'll multiply by 1 and 5 zeros. That's what it means. Okay, that's the idea. Okay, so let's multiply both sides by 100. We're going to multiply x by 100, then we'll multiply this side too by 100. That's what we mean. So multiply x by 100, we have 100x equal to multiply this one by 100. So I said if you want to multiply this one by 100, it's advisable we use this full number. So let's use this full number. Let's multiply it by 100. If you like, you can use your calculator to check that out. Just multiply this full number by 100. But I can easily figure that out by doing this way. 1, 2. So that's 23.23232323 in that pattern. So I'm going to write 23 point. Now I see recurrence of 2 and 3, 2 and 3, 2 and 3, 2, 3 in that pattern. And don't forget that this one also have 2 recurrence digits, 2 recurring digits. So I'm going to repeat the same thing also here. So I have 2, 3. So 23.23. And remember to put your dots on top to show that 2, 3, 2, 3, 2, 3 keeps recurring. Now at that point, your next aim is to subtract and to ensure that This recurring digit will cancel, will take care of itself, so we will not have it in the next step. So subtract. We have 100x minus x, that's this minus this minus this, the second one minus the first one. Okay, so we have 100x minus x equal to 23.23 minus 0.23. Okay, so let's carry out this subtraction. That will actually be 99x equals to, so I like to do the subtraction manually. Make sure there's an alignment of decimal points, subtraction of decimals. So when we subtract, we have 3 minus 3, 0, 2 minus 2, 0, 3 dots, you see, 3 dots minus 3 dots, 2 dots minus 2 dots. So those will eventually disappear. The recurring digits must disappear in this step. So you have 3 minus 0, 3, then here you have 23. So this gives 23. So divide both sides by 99, and you have x equals to 23 over 99. Now you can just double check with your calculator. 23 over 99, if there is a possible means of dividing to the lowest, you divide to the lowest. If there is no possible means, you leave it as 23 over 99. So if you do that, we double check with your calculator, you have 0.23232323 in that pattern. So that is from that exam, from that IGCSE exam in that year. Let's move on to example 3. So this is what we have in example 3. We want to write the recurring decimal 8.24 as a fraction. Okay, so first we know that there are fundamentally 2 recurring digits, 2 and 4. So you know in our process we'll multiply by 100. So let's x equals to 8.24 dots. I like to write it in full beside. I know I actually have 8.24 recurrence of 24, 24, 24 like that. Okay. So we multiply by 100 on both sides. So since we have 2 recurring digits, so we have 100x equal to, now this one times 100. So how do we multiply this one by 100? I will actually use the full length, which is this. So it is this that I will multiply by 100. So it is the full length here that will be multiplied by 100 for simplicity. So let's multiply that full length by 100. Let's see what we have. Let's see. I could just do like this. You can make use of your calculator here. Fine, there's no problem. But I could just figure it out this way. 1, 2. That's 824 points. Another set of 24, 24, 24. If you use your calculator, you get the same thing. So that's 824.242424 keeps repeating. That's 24 dot dot. Okay. So now you see at this step, we're so excited that we'll be able to clear off the recurring digits. So we subtract. Let's carry out a subtraction. Now we have 100x minus x equal to 824.24 dots minus 8.24 dots. Okay, I like to do this subtraction manually. 824.24 minus, I'll ensure that the decimal points are in alignment, 8.24. So dot dot that way. Okay, so carry out this subtraction. We have 4 dots minus 4 dots 0, 2 dots minus 2 dots 0. Those ones are out of it, completely out. 4 minus 8, so that's impossible. We say we carry 1 from here. That turns to 10. 10 plus 4, that's 14. 14 minus 8, that's 6. So this automatically turns to 1 since we borrowed 1 from it. So this is 816. So we have 816 there. So we have 99x equal to 816. Now x can be obtained as 816 divided by 99. Yes, x is 816 divided by 99. But we need to be sure that that is the smallest fraction. So let's double check. 816 divided by 99. 816 divided by 99. Okay, so that's not the smallest fraction. So in the smallest fraction, probably you must have divided through by, let's say, 11. 816 divided by 11. No. 816 divided by 99. Or you can just make use of your natural display calculator. I think it's 3. 816 divided by 3. That's 272. Or just input that into a natural display calculator straight. You can get what you want. So that's 272. Instead of thinking about what divides both. 99 divided by 3, 33. So 272 divided by 33 gives the smallest fraction required. X is 272 divided by 33. So in that way, we have been able to convert the recurring decimal 272, let's double check, divided by 33, 8.24242424, like that. We're able to convert the recurring decimal to simplest fraction. Okay, that's that. Let's move further to a question that looks tougher than this. So let's move. Just have 2 more questions, then we're done with conversions of recurring decimals to fraction. I guess this should be our question 4. Okay, if I'm right. It says, I want to write x. Okay, let's shorten it. So let's shorten it. X. We know that x equals to, right? X equals to 1.256. So recurring decimal. It's a recurring decimal as a fraction to the lowest term. Okay, so after this we'll have one more and we're done with the concept of changing recurring decimals to fraction. Solution. Okay, so we have x equal to 1.256. I like to write it in full. This means 1.256. Repetition of 5 and 6, 5 and 6, 5 and 6, 5 and 6. Continuous, it doesn't have end. So let's just write it like that. Now, let's identify how many recurring digits we have. 1, 2. There are 2 recurring digits, so we multiply by 100. So we have 100x equals to. So let me multiply this one by 100. Let's see what we have. 125.656565 like that. So I'm going to write 125.656565 keeps recurring. So at this point, we need to be very careful so we'll be able to get the actual recurrence. So when we multiply by 100, we have 125.656565. Six five. Okay, something like this. This is what we have. When we actually multiply by 100. Now, our aim is such that the recurring decimal should cancel out when we subtract, and the recurring decimal here occurs at 56. So this is what we now do. So we make sure that our recurring decimal here is also 56. So we'll start here 56. That's recurring decimal. Another one, or recurring digit, 56. Another one, 56, like that. So this is actually 5656. So our result that we're going to use will be the recurrence of 565656. So 125.6, 125.6, then we now have 56 being the recurring digits. Otherwise, we won't be able to eliminate the recurrence of 5 and 6. Otherwise, we won't be able to eliminate recurrence of 5 and 6. Very important. So now let's subtract. So we have 99x, 100x minus x is 99x is 125.656 recurrence, 565656 recurrence minus 1.256 as recurrence. Okay, so we need to use the same as the recurrence so that elimination of that recurrence 56 will be easy, please. Okay, it might appear as if there's a recurrence of 65. If you use that, we'll not be able to eliminate this 56 recurrence that we need. And the aim of the next process or the next step is to eliminate the recurrence of 565656 so that we'll not have any recurring digits again. So let's do our subtraction manually the way we like to do it. 125.656 recurrence minus 1.256 recurrence. So let's carry out that subtraction. We have 6 dot minus 6 dot 0, 5 dot minus 5 dot 0, 6 minus 2, 4, bring the decimal point, 5 minus 1, 4, bring down 2, bring down 1, that's 124.4. So we have 99x, kind of funny answer, equals to 124.4. But once we get to this stage, we notice that there's no recurrence of any digits again. It's just strictly 124.4. No recurrence of any digits at this point. So that means we're still fine with that. But our aim is to convert it to the simplest fraction. So, and we always divide through by 99, okay? So that x can come out. Divide both sides by 99. But there's a decimal appearing here. So we can still eliminate that decimal. Now, how do we eliminate that decimal? To eliminate that decimal so that we can have a proper fraction, we can just say x now is 124.4 divided by 99. We know from our usual process. Now, because this is just a single number or a single digit after the decimal, let's eliminate that single digit. So the only thing we can do, which is a normal mathematics, is to multiply both numerator and denominator. Let's use 10 to multiply up and down. Numerator and denominator multiply by 10. So that we can get a proper fraction that the examiner wants. So x will now be, so let's multiply up by 10. 124.4 times 10, that's 1244. Divided by denominator times 10, 99 times 10, 990. So this is the fraction, and we'll try to see if it can be divided into the smallest fraction. Let's try to use our calculator or natural display calculator could help out. 1244 divided by 990. Oh, the simplest fraction is 622 over 495. 622 divided by 495, and that's the simplest fraction. If you convert it to decimal, if you are using a natural display calculator, you can press SD. That will convert to decimal. That's 1.256565656. So there's a repetition of 56. 1.25656, and that's correct. So I'll be able to double check that. So final answer to the simplest fraction is that. The last question. So here we have the last question. Write the recurring decimal 5.4821 as a fraction. (5.4821) as a fraction. So basically 5.4821 as a fraction, we need to identify the recurring digits. So here are the recurring digits. For a layman definition, we expect that there should also be a dot here, just to show that the recurrence occur from 8 to up to 1, but this is just a standard way we write it, as it is written in the question. But for your own understanding, you can just put the dot there to show that recurrence is starting from 8 and ending at 1. So 821, 821 keeps appearing. So we have another 821, 821 like that. So we have 5.4, 821, 821, 821, 821. So we now understand what the questions actually refer to. So the recurrence starting at 8, ending at 1. So 821 are the recurring digits. 821 recurring digits. So this is the longer version. Alright, something like this. Okay, so our usual method, let x equal to 5.821. Now, what do you think will be the number that will be used to multiply both sides? The number that will be used to multiply both sides is dependent. So obviously, there are 3 recurring digits here, as we have seen. So we'll need to multiply both sides by 1000. So we're going to multiply here with 1000 because of 3 recurring digits. Also this side with 1000 because of the 3 recurring digits. Okay. Okay, so we have 1000x equal to, now our usual method of multiplying this one by 1000 is to multiply the whole full length by 1000. So I could just place this decimal 3 times forward, 1, 2, 3. So the new position of decimal is here. So that's 5482. So I can write 5482. Okay, points. So I start having 0.181821. Okay, so I have something like that, after multiplying by 1000. So that means the recurrence digits occur at 821. 821. So recurring digits occur at 821. Did you notice there's a slight error here? Okay, yeah, so this is actually x equals to 5.4821. So I wrote, so this is 5.4821. Okay, now at this point we can subtract. Okay, now it means I don't actually need this, so I'll be able to identify the recurring digits. So when we subtract, what do we have? 1000x minus x, that's 999x, equal to, I like to do this manually, 5 points, sorry, not 5 points, can have something like 5482.1821 minus 5 points. Okay, let the decimal points align, very important when subtracting decimals. 5.4821. So we said the aim is such that the recurring digits must be eliminated. Okay, so we'll see that the recurring digits will now be eliminated. 0.1 will subtract, takes care of itself. This is also a recurring digit, takes care of itself. So 1 minus 4, okay, we like to say impossible. We need to borrow 1 from 2. So this eventually turns to 1. And that one is actually 10. So this turns to 11. 11 minus 4, that looks like 7. 1 minus 5, impossible. We need to borrow another one again. This turns to 7. That one is actually 10. 10 plus 1, that's 11 minus 5, that's 6. This is 7. This is 4. This is 5. So we have 5476.7. 5476.7. Okay, let's write that in black ink. 5476.7. Okay. Now x can just easily be obtained. Now we're able to eliminate a recurring digits, no recurring digits again, and that's our aim. Okay, so x can be obtained by dividing both sides by 999. X equal to 5476.7 divided by 999. But it's advisable before you carry out this division, you need to observe just a single decimal point, and we want to avoid that. So since there's just a single number after the decimal point, we can multiply by 10. But to do that, we need to multiply up by 10 and down by 10, so that eventually we make the same changes to both. So I think we have something like, look like 5476.74. We'll multiply by 100. That's what it means, because there are 2 digits after the decimal. So this is just normal division and has nothing to do with the fundamental of this. It's just for us to be able to generate a meaningful fraction. So x equals to 54766. By the time we multiply by 10, that decimal will leave, turn to 54767. Well, we need to make the same changes up and down. Divide by, multiply denominator by 10, that's 9990, 9990. So this is the fraction that we want, 9990. So, but we'll have to see, is this actually the lowest fraction? So let's see. So we have this. I can just double check that with my calculator if there's a possible simplest fraction. So I'm going to check 54767 divided by 9990. Okay, so the calculator still produce 5476, still produce the same result. So that means there's no other simple division. So let's double check if our answer is right. SD with a 5.4, 821, 821, 821 like that. So final answer is what we have here. So thank you for listening. You can join me on my YouTube channel for other lectures in the Igcse Math 0580 exam. I'll see you in my next video. Bye.